Hey everyone, this is Sharon. Now I'm going to discuss one of the properties of gamma function called recurrence formula, which states that gamma of n plus 1 equals n into n gamma equals n factorial. Coming to the proof, we know that by the definition of gamma function, gamma n is equals to integral 0 to infinite e to the power minus x into x to the power n minus 1 dx. Using this formula, we are now going to prove the recurrence formula. As we have n plus 1 in the formula, we're going to add 1 to the n, which is gamma n plus 1 equals integral 0 to infinite e to the power minus x into x to the power n dx. In the next step, we are going to integrate by parts. The formula for integration by parts is integration of uv dx is equals to u integration of v dx minus integration of u derivative into integration of v dx. To apply the integration by parts formula, we need to make sure that our equation follows the Eilert rule. According to Eilert rule, exponential terms should be placed later in the equation. So by swapping the positions of exponential and algebraic terms in our equation, we get gamma n plus 1 equals integration 0 to 8 x to the power n into e to the power minus x dx. On applying the formula, we get x to the power n integral 0 to 8 e to the power minus x dx minus integration 0 to 8 x to the power n derivative into integration 0 to infinite e to the power minus x dx. Here e to the power minus x upon integration gives minus e to the power minus x on the integral 0 to infinite, and derivating x to the power n gives n into x to the power n minus 1, and here integrating e to the power minus x is minus e to the power minus x. Here bringing the constant and negative symbol out of the integration gives the following equation. If we look at this term, we can identify that this is in the form of first equation. In the next step, we are applying limits to the first term. So first we substitute the upper interval. E to the power minus x, on substituting e to the power minus infinite equals 0, the term becomes 0, minus, now we are substituting the lower interval, and e to the power minus 0 also equals 0, and the term becomes 0. So 0 minus 0. And the second term, as we know, is in the form of first equation, which is gamma n equals integration 0 to infinite e to the power minus x into x to the power n minus 1 dx. So we can write this as n into gamma n. And finally we get gamma n plus 1 equals n into gamma n. Consider this as equation 2. Here we are left to prove that this statement equals n factorial. If we observe, here we need to get gamma n value. So subtracting 1 from the LHS, we get n minus 1 into gamma n minus 1. On substituting this value in the second equation, we get n into n minus 1 into gamma n minus 1. If we follow the above step for a couple of times, we get the values of gamma n minus 1, gamma n minus 2, gamma n minus 3, and so on. And we get to the statement n into n minus 1 into n minus 2 into n minus 3, so on, 3 into 2 into 1. This is in the form of n factorial. So gamma n plus 1 equals n factorial. Therefore, gamma n plus 1 equals n into gamma n equals n factorial. Hence proved. Thank you.